Good morning, students. Today, let us see the topics binomial coefficient and binomial theorem from the unit elementary combinatorics, that is from unit 3. Okay, so before starting binomial coefficients, let us see the definitions permutation and combination. So, permutation is used when the order matters, and combination used when the order does not matters. So permutation is used when the order is matter, and combination is used when the order does not matter. Suppose there is a 10 students, there are 10 students in a class, and you need to select 3 students to form a committee. Out of 10 students, you need to form 3 student committee. So you can select any 3 students from the 10 people. So there is no order, since a committee, in the committee all the students does the same thing. So in this case, there is no order required, hence it comes under combination. Hence the answer is 10C3. There are 10 students in a class. You need to select a 3-member committee from the 10 students. So since there is no order required, every member in the committee do the same thing. So it comes under combination, and the answer for this question is 10C3. Now let us see an example of a permutation. A permutation in which the order definitely matters. Suppose there are 10 students in a class, and you need to give gold medal, silver medal, bronze medal based on their performances. So there are 10 students in a class, and you need to give one gold medal, one silver medal, and one bronze medal based on the performance of the students. So here, definitely, gold medal will be given to top performer, then next performer will be given to silver medal, then the next performer will be given to bronze medal. So here, the order definitely matters. So here, we will use permutation. Hence, the answer for this question is 10p3. Okay, so the definition of permutation is where the order matters. Okay, and the permutation of the definition of combination is where the order does not matters. Okay, selecting 3 people from a 10 students class will comes under combination, and giving gold medal, silver medal, bronze medal from a 10 student class will come under permutation. Now let us see some rules on binomial coefficients. So there are 12 rules in binomial coefficients. So let us see the rules which are important. So the first one is formula for combination. It is NCR. CNR is same as NCR. NCR formula is n factorial by n minus r factorial into r factorial. It is called representation by factorials. The second one, identity 2, is called symmetric property. It is saying that NCR is same as NC n minus r. Now let us see another identity. Identity number 6. It is boundary condition. It is saying that NC0 equals to 1. And identity 7. It is called secondary condition. It is saying that NC1 equals to N. And identity 11 is the very important one, column summation. It is saying that RCR plus R plus 1 CR and so on, NCR is equals to n plus 1 CR plus 1 for n greater than or equal to R. Okay, so here you can see that the second element is common in all the LHS part, R and so on, R, and in the LHS the first element is R plus 1 and so on, N. Okay, second element is common in every term, and first element is increasing by 1, and the answer is n plus 1 C R plus 1. Okay, so this is called a column summation, and it is a very important one. We have seen totally four 4 identities out of 12 identities. One is the formula for NCR. NCR formula is n factorial by n minus r factorial into r factorial. Okay, then NCR is same as NCn minus r. Then we have seen boundary condition NC0 equals to 1, then secondary condition NC1 equals to n, then column summation, it is r RCR plus r plus 1 CR and so on. NCR is equals to n plus 1 CR plus 1. So in the LHS part, the second term in every term, second value in every term is r, and first value is increasing by 1. So final answer is n plus 1 CR plus 1. So this identity 11 will be used several times in the example problems. Now let us see example 1. So you need to evaluate the sum 1 plus 2 plus 3 and so on n. So we know that it is the sum of first 10 natural numbers, and we know the sum is n into n plus 1 by 2. Okay, so it is sum of first 10 natural numbers. We know the answer is n into n plus 1 by 2, but we need to prove the answer by using binomial coefficients. Okay, so let us start with the nth term. Here nth term is n. Okay, so here nth term is n. So let us start with k. Suppose if the nth term is n square, you need to start with k square. If the nth term is n cube, you need to start with k cube. Since the nth term is n, I have started with k. So from the secondary condition, we know that NC1 equals to N. Similarly, KC1 equals to K. So we have started with the nth term, that is N. So that is K. So and we can write K as KC1. Okay. So for K equals to KC1, I have applied a sigma on both sides, where K running from 1 to N. Okay. I have written K equals to KC1 and I have applied sigma on both sides. Okay. So I have applied sigma on both sides, and the LHS is expanded. When k equals to 1, it will be 1. When k equals to 2, it will be 2. K equals to 3, it is 3, and so on. And since it is sigma, you write plus. Okay. In the RHS, when k equals to 1, it will be 1C1. When k equals to 2, it will be 2C1, and so on. When k equals to n, it will be NC1, and it is denoted by CN1. Okay. So LHS is written as it is in the next step, and the RHS. So we have used identity 11. Identity 11 saying that in every term the second value must be same. So here also in RHS, in RHS of every term the second value is 1, and according to identity 11 the first value has to be increased by 1. So first value is 1, second value is 2, and so on n. Okay, identity 11 is saying that um, in every term the second value must be same. Here also the second value is same, that is 1, and in the first value it has to be increased by 1. Here also it is increased by 1, 1, 2, and so on n. So according to identity 11, it will be n plus 1 C R plus 1. Here n is n only, r is 1, so it is n plus 1 C 1 plus 1. Okay, so that is n plus 1 C2. So now n plus 1 C2 can be simplified using the formula NCR equals to n factorial by n minus r factorial into r factorial. And we know that n plus 1 factorial is same as n plus 1 into n minus 1 factorial. Okay, so n minus 1 factorial, n minus 1 factorial get cancelled. We left with n into n plus 1 by 2. Okay, so the point is, if it is 7 factorial, 7 factorial can be written as 7 into 6 into 5 into 4 factorial. And suppose if it is 5 factorial, 5 factorial can be written as 5 into 4 into 3 factorial. So depending on our requirement, we can write. So similarly here n plus 1 factorial is written as n plus 1 into n minus 1 factorial. Why we have stopped at n minus 1 factorial is in the denominator we have the term n minus 1 factorial. That's why we have stopped at n minus 1 factorial, and it gets cancelled, and we know that 2 factorial is 2 into 1. So finally we got n into n plus 1 by 2 as the answer. Now let us take another question. We need to evaluate the sum 1 square plus 2 square and so on n square. And we know that this is a sum of squares of first 10 natural numbers, and we know the final answer also. The answer is n into n plus 1 into 2n plus 1 by 6. In lower standards, we have proved this by using mathematical induction, but we need to prove this by using binomial coefficients. Okay, so here the nth term is n square, so you need to start with k square. Since the nth term is n square, so you need to start with k square. If the nth term is n cube, you need to start with k cube. Since here it is n square, so we have started with k square. So k square can be written as k square minus k plus k. K is subtracted and k is added. And from the first two terms, k square and k, I have taken k common. Okay, so it will be k square equals to k into k minus 1 plus k. Okay, so we know that kc2 kc2 is k into k minus 1 by 2. Kc2 value is k into k minus 1 by 2. Okay, so that's why k into k minus 1 is replaced by kc2. And we know that nc1 equals to n. Similarly, kc1 equals to k. So k into k minus 1 is same as k into k minus 1 is same as 2 times kc2, and k is same as kc1. Okay, now I have taken sigma on both sides, so it will be sigma k running from 1 to n k square equals to 2 times sigma k running from 1 to n kc2 plus sigma k running from 1 to n kc1. After taking the sigma, I have expanded LHS. LHS is take k equals to 1, it is 1 square. Take k equals to 2, it is 2 square. And so on. Take k equals to n, it is n square. Since it is sigma, you need to put plus. And in the RHS, there are two terms. In the first term, you take k equals to 1, it will be okay. After taking sigma, in the right hand side, the first term is for k equals to 1, it is c 1c2. For k equals to 2, it is 2c2, and so on. For k equals to n, it is nc2. And the last term is